So in this third part, we're doing the final two questions of the Edexcel or Pearson's International M1 paper from October 2016. It's a speed time graph question, and here we got a train that accelerates with a constant acceleration of 1 meters per second, and it reaches a speed of v, and then it maintains that speed, so it's a constant velocity, and then it decelerates. So it's going to accelerate, then it's going to maintain a certain speed v, and then it's going to decelerate. And we got speed and time. But we're told certain things about this. We're told that the length from here to here is t, because that's the time it's going at constant velocity. We're told that it's got a total of 180 seconds. So that's our speed time graph. So that's part A. Part B, now you've got to be careful because it says so that. It's basically all based on the idea that this is 180, and some of you might see very quickly that that length there is v, and this length here is 2v, and so therefore it's not difficult to see where that comes from. But we've got to be quite careful because it says so that, so we need to really show that. How do we know that this is v? Well, it's all to do with the gradient being equal to 1. So let's just say total time is 180 equals 180 seconds. And if I talk about this bit here first, rather than just writing v, because that's a bit dangerous, I can write v divided by 1. V because it's reached a velocity of v in with an acceleration of 1 meters per second, so we can see that's v over 1. You're either using distances, you're either using acceleration is velocity over time, or you're just using the fact that the gradient is the acceleration, which is equal to 1. So that means that v over t equals 1, so therefore you can see where this comes from. Okay, it may seem a bit unduly making it a meal of it, but it's because it's saying so that we need to be careful. Then we've got the t, which is for this section here, and then we've got this 2v bit, but again don't write 2v in because we need to make it clear why it's 2v, or that we're showing it's 2v. So it's v divided by 0.5, which is equal to 180. So that gives me t plus 3v equals 180. So t is equal to 180 minus 3v as required. We've definitely shown it there. That's convincing enough. Right, now we're going to set up an equation for part C. Now I'm going to use the fact that it's a trapezium like that we've got this length, the two parallel sides are 180 and t. So total area, so distance is 4,800, so the area, which is equal to the area. So we've got, it's a trapezium, so that's a half times by v, using the area of the trapezium, which is half h a plus b, where a and b are the parallel sides. So that's half v, that's the distance between the two parallel sides, times by the sum of the two parallel sides, which is t plus 180, is equal to 4,800. Right, instead I'm going to multiply it all out, so I've got v t plus 180 t is equal to 9,600. but we know that t is equal to 180 minus 3v. So let's put that into the equation. Of course, I mean v there. So I'm now going to substitute for t. So we've got v times 180 minus 3v plus 180v is equal to 9,600. So let's multiply all that out. That gives me 180v minus 3v squared plus 180v equals 9,600. Let's bring it all over to the same side. 3v squared minus 360v plus 9,600 equals to 0. Let's divide that by 3. So we get v squared minus 120v plus 3,200 equals to 0. The second time on this paper we've got a nice quadratic that nicely factorises. We know that it's two negatives and 40 and 80. Right, now you might be wondering at this stage why 180, we got the two solutions, v is equal to 40, v equals 80, but we must reject that because it cannot be equal to 80 because of what's going on here. It's all to do with, it's a strange scenario with, just doesn't, the numbers don't work if we've got v equals 280 because of this condition. You can't have negative time and whatever, so we're going to reject that. So that gives us that v equals to 40. Okay, so let's do the final question. Okay, final question. It's a connected particle situation. We're given an angle, so we can often like to, once we've got an angle, is to write what the various ratios are. Tan alpha is 3/4. You can easily work out that sine alpha is equal to 3/5. Cos alpha equals 4/5. The way I like to do that is a kind of non-calculator way. It's a 3, 4, 5 triangle. And we can get the various ratios because we've got tan is 3/4. We can therefore work sine, which is opposite, and whatever. Or you can use a calculator. I think it's quite a nice way to do it, and we don't even have to work out the angle at that rate. We've just got the ratios because all we're going to, and we can just sub these in when we need them. Okay, so that's the angle we dealt with. Now in these situations we're applying F equals ma to both of these particles at some point, I would imagine. But in this question, it's given us the time that this hits the ground. It's obviously going to accelerate down here. Can't do anything else because, wrong way, because of the fact that the 3 is greater than the 2g. It wouldn't be possible to go any other way. So let's work out the acceleration of this because we're told what that is. So if we can see that the acceleration is easy to work out, and then we can just set up our F equals ma questions for part A and B, and it should come out nicely. Okay, so we're doing part A now anyway. So let's just apply to Q v squared equals u squared plus 2as. We know because it's starting at rest. It does say that somewhere. You'll see it's held at rest, so u is equal to 0. We're told that it finishes at 1.4 when it's dropped to the floor, which is 0.5. So we can work out the acceleration here. So we're going to use v squared equals u squared plus 2as. That's 1.4 squared is equal to 0 squared plus 2 times a times 0.5. That easily comes out as a is equal to 1.96 meters per second squared. Okay, so that's not what it asked for yet, but that's going to get us on our way. So if we apply F equals ma to Q, well, if we look at the forces on this, we've got 3g going downwards and t going upwards. So, and it's accelerating downwards. So apply F equals ma in the direction of the acceleration. We get 3g minus t is equal to 3 times by 1.96. So that gives me t is equal to 3g minus 3 times 1.96. So that gives me t is equal to 23.52, but we want to really round that to either 2 or 3 significant figures. 23.5 newtons, or maybe even 24 newtons, because it's definitely rounded up to 24. Okay, so that's part A done. So we know that t is 24. Now I'm going to draw a diagram for p, I think, because it might be a bit small along here. We can look at the forces on p. We've got a reaction force going up like that. Okay, we've got a weight coming down. This is where the angles are all going to come in. It's obviously accelerating this way, which means it's going to be moving this way in this case. So friction will have to come down in that direction because it's going to oppose motion going up. It is moving, so we've got mu r. And obviously we've got the friction, which is this number, which actually worked out as 23.52 newtons that we actually worked out before. So we can apply F equals ma, and we also know the acceleration is 1.96. We also want to resolve perpendicularly, because that's always a good idea, because we need the reaction force. So resolving perpendicularly, we can see the component of this force. That component there is r cos, not r, is 2g, so that's 2g cos alpha. Okay, so we can resolve perpendicularly and say that r equals 2g cos alpha, but we know that cos alpha is 4 over 5. So r is equal to 2g times 4 over 5, which is equal to 8g over 5. Okay, so now we can do the F equals ma on P. So we've got the forces upwards, which is the tension, this force, 23.52. Take away the component of the weight. Surprising a number of people who forget to put the component of the weight in. And that's obviously 2g sine alpha. So that's take away 2g sine alpha, take away mu r equals to mass times acceleration, and the mass is 2 in this case, and the acceleration is 1.96. So 2 times 1.96. Now I'm going to sub in some values and work with this and hopefully see what happens. So we've got 23.52 minus 2g times by 3 over 5 now, minus mu times 8g over 5 is equal to 2 times 1.96. Okay, so it's just now a case of fiddling around and rearranging. So let's just take the mu to the front. So it's mu times 8g over 5 is equal to 23.52 minus 6g over 5, that's that bit there, minus 2 times 1.96. Okay, working this bit out here, 8g over 5 that's 15.68 mu. I'm working out all of this stuff here. That works out 7.84. So when we divide it, we get this here, which gives mu is equal to 0.5 exactly. So we can just leave it as 0.5. And so that's it, the final question of that paper. Okay, hope you enjoyed it. Thank you, bye.